Now let's see this question here where they ask us to do Gaussian elimination method. Okay, so when they ask for Gaussian elimination method, let's revise our step. The first one, we will want to make this 1. Then we will use this 1 to make this 0 and this 0. Next, we'll make this entry here 1. And then use this 1 to make this 0. And finally, we want to make this 1. So let's see, you are given this question here. So first of all, let's change to augmented matrix. This is 2 minus 1, 1. 1 minus 1 minus 1. 2 minus 2 minus 1. So make a separator here and then write this right hand side 2, 1, 3. So now this is your row 1, row 2, row 3. Let us start off with the first one. We want to make this first term here 1. Okay, this is 2. So when we want to make this 1, we have two options. Either we will multiply the first row with half, or we can see down here, do you have any entry with 1? So since we have this entry 1, we don't need to multiply the first row by half. You can just exchange row 1 and row 2. So just write row 1, exchange with row 2. So you just take the whole row 1 and then replace it with row 2, and row 2 will go up here. So this is the result. Next, let's use this 1 here to make this term here 0. Okay, so what should you do? We want to use row 1 plus row 2 put at the new row 2. Okay, so this is the formula that we must follow. I repeat again, we want to use row 1. So row 1 plus row 2 put at the new row 2. So whenever you want to use this row 1 here, you can multiply a number that will give you the answer of 0. So let's see here. The answer here is negative 2, because negative 2 times 1 plus 2, you'll get 0. So this is the equation that we are finding for. Negative 2 times R1 plus R2 put at the new R2. So let's see here. Take the whole row 1 and then multiply it with minus 2. So this will become minus 2, 2, 2, minus 2. And then we want to add them up with row 2. So let's copy and paste row 2 here, and then let's add them up. This is 0. This is what we want. So 2 plus minus 1 is 1. 2 plus 1 is 3. Minus 2 plus 2 is 0. So let's substitute this value here. Okay. Next, let's do this one. We want to use 1 to make this also 0. So what should we multiply to 1? When you plus 2, you get 0. So again, we'll find the value of negative 2. So negative 2 times row 1 plus row 3 put at the new row 3. So now let's do the calculation right here. Negative 2 R1, we want to plus R3. So let's put the value of R3 here, which is 2, minus 2, minus 1, and 3. So we have multiplied minus 2 R1, and then now let's plus to R3 so that we can put it at the new row 3. So this is 0, 2 plus minus 2 is 0, 2 plus minus 1 is 1, minus 2 plus 3 is 1. So let's rewrite 0, 0, 1, 1 and put it here. Okay, next step, let's make this entry 1. This is already 1, so no need to do any calculation. And then we want to use this 1 to make this 0. So this is already 0. And finally, let's make this 1. This is already 1, so nothing we can do here. So we've finished doing all the elementary row operation. So now let's read our answer. Let's read from the third row. This is 0x plus 0y plus 1z equal to 1. So this is our answer. Z is equal to 1. Let's back substitute towards our second row. This is 0x plus 1y plus 3z is equal to 0. So we have y plus 3z equal to 0. And then let's substitute. Our z is 1. Therefore, y is equal to negative 3. And finally, let's back substitute again to row 1. This is x minus y minus z equal to 1. So let us substitute. Our y is negative 3. Our z is equal to 1. And then let's solve. X is equal to negative 1. So finally, let's write our answer. Our answer is x, y, z is equal to negative 1, negative 3, 1. Now let's look at a second example. We are solving the system using Gauss-Jordan elimination method. So let's revise again how to do Gauss-Jordan. The first one, make this 1. Use this 1 to make this 0 and this 0. Next, let's make this entry 1 and use this 1 to make this 0 and this 0. Finally, let's make this entry here 1 and then use this 1 to make this 0 and this 0. Okay, so when we finish doing this, we can straight away read our answer. This is 0x plus 0y plus 1z is equal to c. So z is equal to c. Next, y is equal to b. And finally, x is equal to a. So the first step that we must do is we must make this into augmented matrix. So let's write, this is 2, 0, minus 1 equal to 1. This is 1, 1, 1, 50. 1 minus 3, 1, negative 10. Okay, make sure you have a separator here. So let's see, our first step is we want to make this first entry here 1. Okay, so rather than multiplying with half, for row 1, let us just exchange with row 2 since you can find the value of 1 here. So this is the equation that we must write. R1 exchange with R2. So this is our answer. Next, let's use this 1 to make this 0. Okay, so what should be multiplied to your R1? When you plus R2, you want to put it at the new R2. So let us write what should be multiplied to 1. When you plus 2, you get 0. So the answer here is negative 2. So we write here negative 2R1 plus R2 put at the new R2. Next, let's see for this one here. Okay, we want to make this entry here 0. So what should we multiply to row 1? When you plus 1, you get 0. So here we know the answer is negative 1. That's why let's write here negative 1 R1 plus R3 put at the new R3. So make sure you do all the row operation as what we have done earlier, and then we'll get 1, 0, 0. Next, we want to focus on this term here. We want to make this entry here. This is entry of second row, second column. Okay, we want to make this 1. So what should we do? We cannot exchange with this even though we have 1 in the upper part. Okay, why? Because if we exchange row 1 and row 2, the one that I finished solving will be mixed up. Okay, so you don't want to exchange any row. However, if you have 1 here, down here, of course you can change row 1 and row 3. So since you cannot exchange, the only way you can solve this is you need to multiply something, so you get this 1. Okay, so of course you need to multiply with negative 1 over 2. So negative 1 over 2 times R2, we want to put at a new R2. So just rewrite back all entries. Only you change row 2. So this is 0, this is 1, this is 3 over 2, and this is 99 over 2. So we're finished with that. Let us continue. Let's use this 1 here to make the upper part here 0. Okay, so what should be multiplied to row 2, which is 1. When you plus 1, you get 0. So the answer here is -1. That's why we'll have this equation here, -1r2 plus r1 put at the new r1. Next, let's see here. This is third row, second column. We want to make this 0. So let's write here, what should be multiplied to 1? When you plus minus 4, you get 0. So the answer here is 4. That's why we'll have this equation here, 4r2 plus r3 put at the new r3. So when finished doing that row operation, now we find out that we have 1, 0, 0 here in your second column. Moving on, let's focus on this part here. We want to make this equal to 1. Okay, so what should you multiply towards your 6 so that you will get 1, and then it is 1 over 6. So multiply the whole row with 1 over 6, and others we just copy back. So finally, this is the final yard row we want to do. We want to use this 1 to make this 0 here. So what should we multiply to 1? When you plus minus half, you get 0. So the answer here is half. It is 1 over 2. So let's do the whole row operation here. And finally, for this part here, what should be multiplied to 1? When you plus 3 over 2, you'll get 0. So the answer here will be -3 over 2. That's why you can find this value here, -3 over 2 r3 plus r2 put at a new r2. So finally, we have achieved the reduced echelon form, which is using Gauss-Jordan elimination method. So now let us straight away read our answer. This is Z equal to 23, your Y is equal to 15, and your X is equal to 12. So you can write everything in terms of coordinate. X, Y, Z will be equal to 12, 15, 23.